So good morning, everyone. So as I said, my name is Mario Negroponzi, and I work in ABN AMRO. I'm a software developer, and since something like 20 years, I used to start with the phones, which were just phones at the time, and then I moved to the iPhone after a little while. I work for ABN AMRO, which is a relatively large company, and what we're going to talk about is a goal that we have is to move from long release cycles to very short release cycles and potentially to release on demand. But because ABN AMRO is a large company, we first need to talk about what we are actually doing. And I'm not going to present it just myself, but with some colleagues. And the apps we're working on are, well, first of all, the mobile banking app, which is the core, the central app for our customers. It allows you, obviously, to look at your bank account, but also your insurances, your mortgage, and this kind of stuff. It is the center of what we call the constellation. But we have other apps as well, like Grip, which allows you to look into your financial situation, how much you're spending for groceries, how much you're spending going out, and so on and so forth. But also Tiki, that you probably know, and it's an application that allows you to do send money to anybody in the Netherlands, which just does a bank account, actually ask for money better. And also other apps like Enmer, which is our loyalty app, and there are some few others, but I'm not going to describe them all. But what they have in common is that they are all native apps, and they're developed by teams that work pretty much the same way. So, going a little bit more into details of what we're going to talk about. First of all, Eugene is going to talk about the workflow that we use. And as you can see in the picture, there are a lot of branches and a big trunk, so that should give you some insights. Then Dunia is going to talk about our handcrafted pipelines, which are, well, difficult to handle. Then Jan is going to talk about something which is a tool that we created internally, which is the asset repository that allows us to work in a more integrated way with designers. And finally, I will come back and talk about a little bit how do we do test automation on real devices. So we focus on these parts which we think are a little bit different from what other companies do, and we handle it in a slightly different way. So just not to waste time, I'll hand the word to Eugene directly.
So I'm Eugene Reinetz. I'm iOS developer in mobile banking team at ABN AMRO. I will be the first job in our human pipeline, and we'll speak about exciting topic, workflow in a bank, which could not be more interesting. As many other development teams, a long time ago we started with Gitflow. It looks good. It's the famous picture from the Vincent blog post back 2010, I believe. You all recognize it. And it looks good with all those branches, integration branch, release. Looks good on the paper. In reality, at some point, we faced with these Dumo branches. Yeah, as you can see, there are more merges and branching than actually development. And this is just a couple of hours. Yeah, and not just this, but also some other exciting features like long-lived feature branches, massive pull requests, code reviews focused rather on new code than on source code, epic merges, with the epic merge conflicts, of course, broken builds, and as a result, long release cycles. If you think about it, the root cause of all those issues is this. So the main feature of the Gitflow is the main problem. And that's how we came up with this trunk-based development. I like this pretty accurate definition from Paul Hammond. So trunk-based development, a source-controlled branching model where developers collaborate on a code in a single branch called trunk, or master in our case, resist any pressure to create other long-lived development branches by employing documented techniques, we will speak. And they therefore avoid merge hell, do not break the build, and live happily ever after. Sounds good. OK. How it might change our workflow, how it's changed. So we used to have this. You can see feature branches You can see some feature development happens there, and 2 releases. Partially developed features, they just stay on the feature branch. They're not included in releases. That's how we separate new development from the releasable code. When we switch to trunk-based development, we have just 1 branch. And partially developed features are hidden behind the feature toggles. So in this case, feature branches become feature toggles. What's that exactly? Feature toggles, or feature flags, are a powerful technique allowing teams to modify system behavior without changing code. Toggles introduce complexity, and we should also aim to constrain the number of toggles in our system. Empirically, in our case, we choose 11 to be the maximum number of feature toggles at any time in our code, just to avoid side effects and mutual interference between the features. So we got rid of long-lived feature branches, and we have no merges. We have no merge conflicts, no code freezes to do those merges, and no pull requests in banking application. You might ask, really? Yeah. We're doing something different. We employ other techniques to do code review. We do pair programming. We do post-commit reviews. Those are not just focused on the new code, but on the whole module. And we use static code analysis tools like Sonarqube. And my colleague Dunya will tell more about it later. But just a sneak peek, it's a screenshot of Sonarqube dashboard. And we measure some metrics there, like technical debt, code smells, and bugs. And since we started, you see, just 7 months ago, since we started trunk-based development, and since we started to focus on the code quality using the Sonarqube and improving it, we see that actually it's going better than it used to be. So we can live without pull requests. So now how it actually helps deliver faster. We don't have those feature branches, right? And so we don't have those bottlenecks related to feature branches. And code on develop is always releasable. And then we can have even shorter release cycles. Now we have bi-weekly releases. But we are aiming to have nightly releases, because it's also possible. And we have increased code quality. As a bonus, we have clean Git graph. So now we have space for some smiling cat. I am handing over mic to my colleague Dunya. He will speak about pipelines.
Thank you. I'm Dunya. I'm the iOS developer of the Grip team, and I'll be talking about the pipelines. Of course, as Eugene mentioned, workflows are one of the main tools with which we sort of improve our release cycle time and so on, but that's not the only thing that we have in order to achieve this. The main, well, not the main, but one of the biggest things is, of course, automation. So if you want to release faster, you have to actually automate everything you can, right? And at ABN, we love automation, so we try to do as much as automation as we can. We automate our testing, unit and UI testing. We automate the whole building process. We automate how we synchronize localization, so our copy, basically, with our external copy platform. We automate our linting process so that a linter checks our code and tells us how to write better or cleaner. We automate the whole certificate management. We automate the whole provisioning profile management systems. We automate the whole delivering process. And that's actually it. So we try to automate every single step of our release process. In sort of a big picture, this is how it looks like. So it goes from left to right. First, of course, a developer has to write his code. Then that gets pushed to our automation system, for which we use Jenkins, actually, which you probably all know. Jenkins picks up the commit. It starts running the unit tests. It starts running the UI tests using Sauce Labs, which my colleague Mario will be talking about at the end of the session. If both of those succeeds, of course, we go to the build step, where we actually create the binaries that we're going to deliver to where we want to deliver them to. Once the build is done, we go to Sonarqube, which is a tool I'll be quickly showing in a minute, where we check our the quality of our code, basically. I'll deep dive into that in a minute. Then we go to Nexus, which is another tool we'll be looking at. After Nexus, basically the whole preparation part is done. Then we move more to the CD part, so the continuous delivery part, where we will deliver to an alpha channel. Could be Hockey App, could be Crashlytics, whatever the application uses. After the alpha channel, we go to the beta channel, which is in our case test flight, of course. Finally, we send a mail, and we're done. This whole pipeline is not what we go through every time we commit. Of course, this is kind of configurable depending on the project, depending on what you're trying to achieve. So if you're trying to make a release, we will basically be going through the whole thing. But if it's just a daily commit you did on the trunk, we disable some of the steps because we don't want to, for example, deliver every commit to test flight just because it doesn't make sense. So we can kind of configure these depending on the project or on the type of action you're doing. So I'll be taking you through each and every step, actually, to deep dive a bit more into what we do. It's no magic. Most of you actually already know we use Fastlane to run unit tests, a really convenient tool by Felix, and the communique, of course. After Fastlane runs our test, we use another Ruby tool called Slather. Slather is a great tool, actually. I don't know if you know it, but if you don't, please do go check it. It can read your test results, and it will generate code coverage reports for you. It could generate HTML formatted reports. It could be a JSON report. It could be a LLVM call. So it can basically push out any type of report you need. Really handy if you want to search through your code coverage, see the, I don't know, the top 10 least covered classes in your application. This is what we use for it. Next to Slather, we also use Xcode, which is again another code coverage tool. You might ask why two? Well, we have different systems requesting different type of code coverage reports, and Slather can do most, but not everything. So for some, we use Xcode, again a Ruby tool, by the way. And this step fails the pipeline. So of course, when we push, and if the unit tests fail, we don't want to go through all the rest of the top pipeline. There's no reason to do it if you have bad code. After the unit tests comes the UI test step. We again, of course, use Fastlane. Same story. What's interesting about our pipeline with the UI test bit is the Sauce Labs integration we have, which is a recently acquired tool at ABN AMRO. Mario will be telling you more about how we deal with it. But basically, we can make a binary and the test binary. We can upload those two to Sauce Labs, and Sauce Labs will run all our tests on different devices, on real devices. It will, of course, fail the pipeline. We don't want to ship out bad code, as usual. And that's actually the UI test step. After that, if all goes fine and everything's tested and it's all green, we start building the app. So we can use Fastlane, of course, to create the binaries we need. We usually make two types depending on what you're doing, but we make an enterprise build so we can distribute it on an alpha channel, or we make a release build to distribute it directly to iTunes Connect. There's an interesting step in this, step, which is the removal of the feature toggles. As Eugene mentioned, we don't have branches. We have branching by abstraction, so we have in the code we have feature toggles. And of course, when you're shipping something out, you don't want to ship out half implemented features. And if we know that a feature toggle exists, we actually know that it exists behind the toggle for a reason. It's because it's not finished yet. So we disable all the toggles so that whatever we're shipping out is actually code we want to ship out and not sort of unfinished half pieces of code. And if also fails the pipeline, because I can't deliver a binary to iTunes Connect if I can't build a binary. And then comes one of the interesting steps we have in our pipeline. It's called Sonarqube. It's a third-party library. You can buy it. You can use it. I think you can use it free on your local machine, and on the cloud I think it's paid. Not sure. Check it. It's a wonderful tool. We use, again, Fastlane. Actually, we use Fastlane for everything, so you'll keep this coming up and up again. Sonarqube is a static code analysis tool. It can do a lot of things for you. I'll be showing it in a minute. Most importantly for us is the code duplication method. It can check and find duplicated pieces of code. Could be a function, could be a single line, could be a whole class that gets duplicated in your class. Of course, you don't want that. You want dry code, as dry as possible. And it will also document your code coverage over time. What Slather generates is, of course, code coverage of that commit, and you're more interested in the fact that your code coverage is not dropping, or preferably that it's increasing. So to keep the change of the code coverage over time, we actually use, again, Sonarqube to see how it's evolving. And it does not fail the pipeline. Well, sometimes, it's good to have all these static analysis. It's good to know what's wrong, what's could be improved in your code, but it's not per se bad code. So we could actually continue delivering our binary if Sonarqube fails for some reason. And this is a small screenshot from another page of Sonarqube which we have. You're looking at the iOS grip app. Basically, it's grouped in 4 groups. It's divided in 4 groups. The top group is showing you bugs and vulnerabilities. What they mean with bugs and vulnerabilities are stuff like hard-coded passwords, it could be, or configuration that lives in code, which should be extracted to a configuration file. Could be, for example, a URL if you have a testing, a staging, a production environment, how you would prefer to get those URLs out of a configuration instead of having it in your code. So all these things will be detected by Sonarqube. In our case, we do have a lot of URLs in the app, which we should extract, so that's why you're seeing the 11 on top. Below that, you have the code smell, so all these code smells like feature envy classes, classes that do too much, long functions, long classes, all these standard code smells I hope we all know. They get detected by Sonarqube, and Sonarqube actually kind of converts the number, so 587 code smells we have apparently in our code, and it kind of maps that to the amount, the depth you'll have to spend to get that fixed. So in our case, apparently we have to buckle up and spend 10 days, more or less, to get rid of those 587 code smells we have in our code. Below that we see the code coverage, which is 88.2% at the moment, and at the bottom we see code duplication, so it will show you how duplicated functions, duplicated classes, and so on. Unfortunately for us, it's about 3%, which is not that good. And the right side actually shows you the latest commit, so the latest commit we pushed in for the code coverage case, for example, it didn't change the code coverage, that's why I'm seeing a sort of static line, a parallel line to the ground. The same with duplication, but I can see that my latest commit actually added 7 minutes extra code smell to my code base, which I'm not proud of, I'm ashamed of. Still, I'm open, I'm sharing it with you. Luckily, I introduced no vulnerabilities and bugs. So this is, in a nutshell, what Sonarqube does for us. After Sonarqube, so if all the tests go well, if we can make a binary, and if we are kind of sure that we have clean code, let's say, then starts the continuous delivery part of our pipeline, basically. First part is Nexus, probably a tool none of you ever heard of. It's kind of like a Dropbox, let's say. It's some server you put somewhere really huge, and you can just put anything you want in it. It's a file system, nothing more than that. You have to use this in a bank. Of course, we have to document every step we do. We have to make sure that everything is there. If we would release a version, for example, last week and something went wrong, there should be a way of getting that build again and testing and verifying that things broke over time. That's why we use Nexus. So every XC archive we make in our pipeline gets uploaded to Nexus as sort of a reference, let's say, so that we can always pull it back and rebuild the binary if we have to. So it's more handy for our release management process, let's say. So of course, in a bank, we have different departments. A department is responsible of releasing the app, let's say. So they want to know that there's somewhere in Nexus a folder with that version, and if things go wrong, they can always point it to that version so we can check it out and run it. It will fail the pipeline, because if we can't document what we're going to upload to the store, then we want to stop, actually, because something undocumented shouldn't go live. That's the Nexus step. Once Nexus is done, so we made the official part of our delivery sort of ready, now we can start the non-official bit, let's say. We do an alpha release. It could be, as I said, for some cases we use CrashEdX Beta and for other cases we use the Hockey app. It's more meant for internal distribution, so every commit we push will get built and will get uploaded to one of these test channels, so that our tester from our team can download it from that tool and start testing the app, basically. So we use it for internal distribution. It's meant for our testers, as I just said, and it will fail the pipeline, because if a tester can't test a certain feature, there's no reason to continue delivering it to the iTunes store. We have to make sure that a tester actually approves the app. That's the alpha stage. After that comes the beta stage, in which is of course meant for external distribution. So the Hockey app channel was of course meant for the people in the bank, let's say, and beta channel is people in the bank, including some people outside of the bank who are sort of our beta testers. We use the iTunes, the test flight system for it. It's meant for our pilot users, what we call, and it will of course fail the pipeline, because if we don't get feedback from our pilot users saying that it's a good app, we don't want to go live. And last but not least, the most important bit of our pipeline is sending a mail, just to let everyone know that we have a release, that we went through all the stages and that everything was fine. So we're basically letting the world know. You might ask yourself, a mail? Yeah, a mail. Why not? So you can go through your inbox, search through 500 other mails, and try to find the right release thing. I'm joking, actually. We, of course, have the mail more, again, for reference purposes, how the bank requires us to sort of put every release in a mail so that it's somehow documented and back up somewhere. We do use Slack for the actual thing, so developers don't open their mailboxes and check if there's a new release. We actually have a look at Slack. We have a nice Slack integration, so we get a notification if something breaks in our whole pipeline, so if the unit tests fail or a delivery to iTunes Connect fails, any stage, if it would fail, we would get a notification in our Slack CI channel, let's say, notifying us what happened, or when the whole pipeline succeeds. So sometimes you just want to push, and of course, this whole pipeline takes, let's say, 10 minutes, 12 minutes, whatever. You don't want to sit there looking at staring at your screen for 12 minutes long just to know that you finally uploaded to iTunes Connect. We do get a notification in Slack saying, hey, it's up there in iTunes Connect. And we also post a direct link in our Slack integration, so you don't have to go through Jenkins pages and try to find your project. You can just click on the link and you're there. What it kind of looks like is this. So on the top bit, I'm seeing a failed builder. Bob the builder just let me know that there's something wrong. It tells me that the unit test failed for a certain commit. And luckily, Parul picked it up. She's always like that. She just rushes into it, fixes it. Another example is a successful build, so everything went fine. And if I would just click on the link, I would get the right Jenkins job, and I would see that it actually got uploaded, went through the whole stages of the pipeline. On top of that, in order to help us monitor a lot better how the pipeline is doing, we have build monitors. They're of course really in your face because we have multiple islands, let's say at ABN, and every island has one of these build monitors right in the middle of the island. So everybody, when you come into your work, that's the first thing you see, the build monitor of Jenkins, and you see all the jobs you have that you care about and what the status is. It's next to every team, as I said, and you also see who committed, what the coverage is, etc. So you get like these basic informations which you kind of want to know, but you don't really want to deep dive into Jenkins to figure out what the latest coverage was. Is all on the build monitor. And it shows a couple of extra stats we basically take out of Sonarqube. So Sonarqube was giving all the stats which I just showed you. We basically extract those, we put them all on the build monitor as well, so you don't have to keep an eye on Sonarqube all the time. Unfortunately, our build monitors don't look like this. This is out of a hacker movie, I think. Our build monitor looks a bit more like that. It is a bit ugly, but it gets the job done. This is a standard build monitor from Jenkins, actually. It's just out of the box. In this case, we're looking at a team of the mobile banking group, and apparently this team, the ROC team, cares about certain things. They care about their Android pipeline, they care about the release health check, etc., etc. So there are different jobs they care about. Of course, internally we have hundreds of these jobs, but in your build monitor you can specify what you think is important for your team. So you can see, as I said, the unit test coverage, who did the latest commit, what the bunnies are, as in what the code smells are, etc., etc. We can see the committer, we can see that a certain job failed, we can see that a certain job is in progress. So everything's in our face, it's next to our island, and we live with this every day, basically. A bit about the future. So we are actually, thanks to the trunk-based development, thanks to this pipeline we are able to release bi-weekly. We're not having any issues with it, and of course we want to improve it more and more so that we can basically release anytime we want on the press of a button. There are, unfortunately, in our opinion, or in, I think the general opinion about it, is that some things can't be automated. And by some things, I'm mostly trying to mention the penetration tests we have at the bank. Since we're making financial apps, of course, we have to make sure that your data is secure and that the app is not easily hackable and so on. This is the core of our business, to make sure that our customers are trusting us and that we're delivering proper products which are not easy to hack, or at least unhackable. And to make sure of that, of course, we could automate some parts of this, but preferably we don't want to automate it, because a hacker is, of course, not a script who's trying to hack your app. A hacker is a person who would think about how to somehow get into your app and somehow get your data. And in order to sort of duplicate that, we have actual penetration testers, a big group of people who get our apps, they run it, they try to hack it in any way possible they can. They will install it on a jailbreaking device, and they'll try to get whatever data out of it that they can. And we have to make sure that this goes correctly, of course, because you don't want your data to be lost to some hacker. So that part is, I think, for the time being, at least until we know a really good way of doing it, won't be automated. It will be done always manually by a good team of testers. And some things we still want to automate, but we didn't do yet. We're constantly evolving on our pipeline, and our two things we actually want to add recently. First being the localization. So some things, all of our copy is being set into a system. They are pulled via a script, etc. But we want to automate that process a bit more. So when a copy writer basically goes to this website and changes a copy, that we automatically get aware of it, and we automatically can pull it and remake a build and so on. So this integration with a localization system, we would like to improve on that. And the last thing we want to add is the asset system. My colleague Jan will be actually talking about how we deal with assets in our apps. And the thing you'll see in a minute, we would actually prefer to have that in the pipeline so it happens automatically. And we just write code and only focus on code. That would be the ideal world for us. So I'll be giving the word to Jan. He'll be talking about the assets repo.
Hello, my name is Jan. I work for ICE Mobile, and since 1.5 years I'm in the mobile banking team. So I'm happy to be here and present you the asset repo. So yeah, what is it? Basically, it's quite easy. It's a script-based asset management tool. But I want to emphasize how the tools can change also the way of working, and I think that's kind of what we present here as a whole. So it's, for one side, it's actually work for the developers, but it's also work for the designers. And it is a system, to verify that all the assets are in place. So basically what we do, we don't put the assets in the zip file or something, but we put it in code, so we can also verify that the assets are there. So why do we have it? Well, it's quite easy. We want to have a more pleasant way to work with the designers, and especially if they want to change an asset or something like that, we don't have to go to Zeppelin or something like that and grab the new asset and put it in our code, but actually we move this responsibility to the designers. So what does it solve? Well, first of all, it removes some workload from us by giving it to the designers, and also kind of clarifies responsibilities between the designers and developers. So basically, the designers, they can break the build, so they also have a bit more responsibility to get the working build out. So maybe they feel a bit more involved. What else does it solve? As I mentioned, it checks that all the assets are there, so there's some quality assurance. It also puts all the assets in one place. So we convince the designers to use Git to put their assets there. And we enforce some naming convention, which makes it also easier for us to find assets back or to have them more organized and all these kind of things. What else does it solve? It has a version control for images, which I'm not sure how much this has been used, but we do have it. And how is it used? Okay, it's quite easy. We have the designers making the designs and adding them to their repository. And as developers, we just run a script to import them. And as Dunja said, this is in the future going to be automated, hopefully. And here's a little graph which kind of shows the way of the workflow. So we have the designers, and they make a design, put it in the design repo. They also put it on Zeppelin, so for the layout, but usually we don't get the assets from Zeppelin. Then, as a developer, we run the script, and what the script will do, it will create the asset archive we use in Xcode, and it will also auto-generate some code. And in the end, it will push that to our code repo. So in the end, we have duplicated the assets, but I think that's not a really big issue. So I have here a little graph which kind of should make more clear how we handle the file naming and the enforcement of the naming convention. So, for instance, we have This is the file name. So it will end up in the asset catalog as core icon and then the actual asset. So you see we have this naming convention that will say core, and that's the first folder, and then we have icons in the core, which are used like over the entire app. If we would have a different folder, it would be payments or something like that, and we have icons or something like similar. It will auto-generate some code. Currently, it uses enums to have some kind of namespace there, and it will make like assets, core, icon, which kind of reflects the same structure as the file name. And in the end, there is a class which is called image asset, and this will be just a static asset which has the name of the asset. In the code, you would just use it like that. For instance, you want to grab the image from the asset, so you say, okay, let the image be the asset core icon back image. And then you can assign it to your image view. So let's say the designers don't care about, they make a new asset called new back asset. They will just drop it in their repository and tell us, hey, I'm updated the assets, so we have to run the script again, and it will end up in the core, the code, all fine. In case they remove the asset, it will break in this step, in the last step in the code, and the pipeline will break. So we see, okay, there's something wrong. And in the future, we want to save a bit more time, so we want to automate that and put it in our pipeline. That's about, very shortly, about the asset repo we're using. So now Mario will tell you something about the test automation.
Yes. So this is the very recent addition to our pipeline, and of course we all have the problem how to test on real devices, possibly all of them. So we have some requirements. So we started our request. So we have some requirements. And of course we cannot test on simulators. That's not enough. We only want to use native frameworks. In the past we used Cucumber and Gherkin. That created more problems than it solved. And sometimes it breaks. So we just decided, okay, we don't want to use wrappers or more high-level frameworks. We just want to stick with the XT-test. So we had some other requirements. Of course, we had to support also browsers and mobile devices because, of course, it's we want a tool for the entire bank, and we develop websites as well, obviously. It has to be hosted in the EU. This is a strict requirement from compliance department. We cannot have our data in the States, for instance, and that creates some issues because most of the providers are actually in the States. And we don't want to have tests. So as I said, we don't want higher level frameworks, and we also don't want extensions. So some stuff that it's proprietary to a vendor, and then if we change vendor, then we're screwed because it doesn't work anymore. And also we want private devices. And this is important because these devices might have access to internal servers of the bank. So we don't want those devices to be shared with anybody else. Because there is a VPN there, and that connects with the internal of the bank. And of course, a requirement is that there is a VPN. Possibly also it has to be easy to integrate in the pipeline. If I have to spend months in the integration, of course, that's not fun. So we went to a number of vendors, and we decided to adopt SOSLab, which on average was for us the best. So just to have a very quick look of what it looks like. So these are the devices that we have. So these are, as you can see, they're all labeled private. There are some devices which are public. We can still run stuff on public devices, so public devices which, after we use them, somebody else can use. But there are restrictions on what we can test on those devices. For each device, you see the device. You can specify the iOS version, so they keep also older iOS versions, which is actually handy, because we have policies for keeping compatibility with older iOS versions. And there are some tech specs which for iOS they're not that useful. We use the same tool also for Android, where of course it makes more sense. What is interesting to note is that there is an ID for each device, so we can select it during the test. This is another screen of the same tool. So this after a test execution, in this case it failed. We know on which device it ran and which build it was. We have the results of the test. In this case, these tests were failing, and we have just a quick results. We can take screenshots. So during the test execution, we can take screenshots. In this case, in this run, there were no screenshots, but you can do it. And it also takes a video, and that's very interesting. So you can get an entire video of the full session. And this is important because sometimes tests fail actually because there is a system pop-up that come up, and you just don't expect it. And the tests keep waiting because you try to click somewhere, and there's somewhere it's just not clickable. So the video is actually very handy to detect this kind of errors that eventually time out, but you don't know why. And then you see the execution, like if you were on a console, and that's exactly identical. It's like having Xcode attached, and it just works like that. And when it comes about the simplicity of the integration, this is the nice part. So it's a single line in which you basically specify, well, it's a Java application, it doesn't matter. You specify that in a CUI test, you give it the API key, which is related to your application. You give the app to be tested, and then the runner app, which I didn't know it existed before this, because I always did it from Xcode, and it creates it behind the scenes. But there is this runner app that is created when you select the test target. You can give it a name, and we enforce that it's running on data center. In this case, we are not specifying the device where the test has to be run. You will randomly select one of the devices available. This is very handy because UI tests take quite some time, so they are decoupled from the normal pipeline, and they run periodically. And we want them to run on pretty much any device, but we also don't want to run half an hour and then run on every device every time, because those devices are also used by the rest of the bank. So we don't want to block the entire data center for that. So with this setup, it just selects one which is available. It can be an iPad, it can be an iPhone, and it will just work. You can also limit and say only iPhone or only iPads. And finally, there is also another functionality which is also handy. So you can interactively go to the browser, go to a specific device, install the app that you're testing, and interactively test. So click left and right in the browser. It's not perfect because you cannot do everything. For instance, it doesn't support multi-touch. Swiping is supported, but it's kind of lagging. You see us a drawing of a line and then it does a swipe, so it's a little bit strange. But it does work, and you get the console to the right, so you can see what's going on. You also have another bunch of settings. You can rotate the screen. You can do stuff. Of course, these devices are in a data center somewhere in Germany. For instance, the camera works, but you see just the black thing because it's in a drawer basically. So that's not very handy. But you can do a lot of stuff. And with this, I think we're done.